assume that you are going to storyboard through sketches, is really all about this working through a design thing. It's working through the process because you're not drawing the finished product. Your storyboards, probably, your interface is not really going to look anything like that, but it gives a description and a depiction of what your system is going to be and how your system is going to be used. So it's all about providing the story behind the finished product that you are going to present. So some of the interesting and important things when you're storyboarding that you need to include are the context. So this scenario has context. You know, it's being done, the sound's going off at 2:30, and that's important because that's when the financial markets are open, so that's something that indicates that something interesting might be going on. So it's all about the context. You want to show the interface. You actually need to show both together quite often, how the interface is being used within the context you're setting. And importantly, it's about the sequence. It's the sequence of events. That's what the storyboard needs to show you. And so therefore, it's usually going to be more than one image because you can't really show a sequence through one image. So let's move on to idea refinement. Idea refinement is done using prototypes. So prototypes depict an aspect of your final system. And a prototype is usually going to be one manifestation of your design. So you might pick one of your sketches that you like, and then you make that look better so that you can show it to your users and get some feedback. So the difference between sketching and prototyping, which I'll come on to in more detail later, is that sketching is about idea exploration, trying to get more ideas and get better ideas. Prototyping is about trying to refine them. So it's not just generation of ideas, it's deciding which bits work, so it's all about evaluation of the system. So when you are prototyping, you're probably usually going to be emphasising one aspect of the system while de-emphasising others, because that might be the thing that you're trying to focus on getting right. So for example, people often prototype buildings in two-dimensional models. Okay, you might have a drawing of a building, now obviously a building is in 3D, but you can still explore the space relationships through a 2D model. You don't actually need the full 3D, and you're probably not interested in the materials it's created with at that point. So you're not focusing on sort of the materials and the building stuff, because in this type of prototyping, you're actually interested in the relationship between the spaces. So it's that kind of idea. And the reason that we prototype is that you can have a design idea that satisfies all of the requirements that you come up with. But that doesn't mean it's the best design and it's the best solution, because there are a number of different ways you can meet each requirement. So you need to evaluate kind of which ones work best. And what this is because prototypes are really about traversing the design space. They're about exploring the design space, but of a more finalized concept. So one of the strengths of prototypes is that they are incomplete. Okay? It is not a perfect representation of your system. It should not be a perfect representation of your system. Because it's quite possible to examine the strengths and weaknesses of a design without actually building a complete copy of what it's going to be. And this is all about this idea of focusing on particular aspects. So having said that, your prototype doesn't probably need to be presentable, a bit more presentable than your storyboards and your sketches, because you are going to show it to people and you probably are going to show it to your users and do some kind of user evaluation, which we'll come on to much later on in this lecture series. But actually, how presentable does it need to be? And that's where you come into this idea of classifying prototypes. So you can have different types of prototypes. The standard classification is that it's either high or low fidelity. A high fidelity prototype basically is a complete mock-up of the finished system. It looks how it should, it's going to, it interacts the way it's going to, the data is representative, and that is what a high fidelity prototype. On the other side, you have low fidelity prototypes, which are prototypes that don't really look like like the finished product at all. So they probably look more similar to your kind of sketches than, I don't know, like an HTML mock-up of your system. So with a low fidelity prototype, you might actually, you're probably most likely going to be using materials that are very different from those that you would put in the final system. So low fidelity prototypes often use cardboard and glue and scissors and things to make them, rather than actually an electronic screen. So why is this a good idea? Well, one of the main things is that you have these 5 dimensions. 5 dimensions of prototypes that you want to think about. And each of these dimensions can be low or high fidelity. So I'm going to go through each of them now. I'm going to start in the middle because I'm weird like that, and I want to keep you concentrating. So we'll start with look. Okay, so the look of your prototype. If it's high fidelity, it's going to look like the finished product. If it's low fidelity, it could just be a pencil drawing. Now, I think I've talked to some of you about this before. Because in terms of fidelity of look, actually having a low fidelity looking prototype, a prototype that doesn't look like the final product earlier on in the design stage, is going to be more useful to you. Now this surprised a few people when I told them, but here are my reasons why. Why a low fidelity looking prototype, something that doesn't actually look that close to the final system, is going to work better. If we can remember that our objective here is to refine our ideas, imagine I give you as a user an HTML mock-up of my web page. So it's not got the interactive functionality, but the CSS is beautiful, it looks perfect. If I give this to a bunch of users and I say, please critique my product, it looks like I put a lot of work into it, okay? It looks like it looks really beautiful. It's a beautiful piece of work I presented here, and I've spent quite a lot of time doing it. Users can tell that. People you're asking can tell that, and people tend to be quite nice. So they might not be as critical of the look as you want them to, because they don't want to be critical of a product that looks like it's almost finished, because they don't want to waste. They think they're wasting your time. The other thing is that if I present something that looks how I think it's going to look in the finished product, although people don't want to criticise something that's almost finished, if you give them something that looks pretty and they don't like something about it, that is what they will focus on. So even if you are also, with your prototype, interested in thoughts on interaction and the breadth and depth of data, actually they will tend to focus on giving you feedback about the font or the colours or this, and that's actually not what you're interested in at that point. So later on in the design cycle, you can give them a high fidelity prototype in terms of the look and the aesthetic, but actually early on, that is quite a big mistake, and it does have consequences for how you're going to refine your ideas. So that was look. Let's do breadth next. So breadth and depth are quite clearly related to each other. This is about breadth and functionality. Okay. So how broadly is the functionality represented within your product, within your prototype? Sorry. So let's have an example. Maybe I'm developing a prototype for a banking kiosk or something. If I'm doing a broadly functional prototype, I would have mocked up versions that include many of the various functionality requirements in my system. So I might have done some mock-ups for the withdrawals, the deposits, bill paying, any sort of this broad range of functionality that my system should work through. So this gives you the user a better understanding of the kind of range of capabilities of the product, of the prototype, and what the interface is ultimately going to provide. And it also gives the users opportunities to challenge like system-wide issues. So if the navigation doesn't work for them, if I've got mock-ups that contain all the context, because I'm doing quite a broadly functional prototype, that makes it easier to demonstrate that. On the other sort of flip side, you can also have depth of functionality. So that is talking about to what level of detail any one of the functions is represented. So it might be that I am really interested in the process of placing, paying a bill through my banking kiosk. And I'm not sure that that's working in the design I've made, so I mock it up as a prototype, and I go through the entire process. So I go very deep through this particular aspect of functionality, and then I go on to talk to users about it. So that gives me the advantage of following through the process. I can show them step by step what it's going to do, and that means that I can make sure that particular aspect is working how I want it to. So that's how breadth and depth work. Then we're going to talk about richness as the interactions. So this is all about how the interactive elements work. So this is things like how the system responds to a user input, how the transitions work between screens or between aspects of the system. So you can represent these through things like page prototypes. So I can have lots of drawings, and I can demonstrate how they sort of link together and stuff. We're going to come on to interactive prototyping. That's the whole focus of the next lecture, so I'm going to kind of leave that there as a kind of stepping stone. But actually, one of the other really important things that we need to think about is the final dimension, which is data, and the richness of the data that you're including within your prototype. So again, here's an example to describe how this works. It's high fidelity if the data that you include in your prototype is real data. It is stuff that is data and content that is going to exist within your system. It's low fidelity if you've just kind of made it up and it's a representation. So a real example of this is, how about if I am developing a new interface for a TV system, so a kind of menu navigation, like the TV guide thing on a system. There's two ways I could do this. I could take real data from the TV guide, so I could have all of the however many hundreds of channels there are, and I could include them as real data within my prototype. That would be high fidelity. Or I could just say, well, actually, I don't really want to go that far down with the representation bit, so I'm going to have a mock-up of the data. So I might just create like 4 channels. I'll call them channel 1, 2, 3, 4, 5. 4 channels, and then I go to 5. Clever like that. And then I might just sort of make up some sort of TV schedule, and it wouldn't be real. So there are advantages of doing that. One is it's quicker. It's probably easier to mock up than something that's real. And the disadvantage is that if we remember this is all about idea refinement, well, what happens if in our system we've only got quite short, our mock-up we're only using quite short strings of text, we're actually only looking at 4 channels, so we're not really considering how it works with hundreds of channels. Do our ideas expand to fill the hundreds of channels model? But also, you can have, these systems often have sort of timing screens and sort of calendars and sort of, going along the timing. I'm sure you've all seen them. And what happens if I've got a half-an-hour program with a very long name? Does that work in our interface? Well, if I'm using real data, I'll probably find that out quite quickly. If I'm using a mock-up, I'm only going to find that out if my data actually is representative of the real data. Yeah, so that's any queries on that? Does that all make sense? Yeah?
Does that mean that we should come up, if we're making up data, we should come up with the data separate to the interface so it doesn't automatically work with the interface?
Are you talking about designing at this point still? Or
No,
so, okay. I'm not entirely sure I understand your question. I mean, there's 2 ways you can do. You can take real data, and that it really depends on what the point of your prototyping activity is. If you're trying to make sure that the data works within your system, then using real data is the way to go. If you're just trying to make sure the interactions kind of work, then if the data that you're making up kind of aligns well with the real data, it's just a simplification of it, then it's okay. But you do need to look at the real data before you make something up so that it does sort of have some kind of similarity. Does that answer your question? You're allowed to say no if I've misunderstood your question. Okay, so the main way of doing static prototyping is to use wireframes. Wireframes are quite like sketches, but not the same. Okay, a wireframe and a sketch is different, and the reason they are different is because of the purpose. So I wireframe, which is basically drawing an aspect of the system again. I do that to refine my ideas. So this is when I've got quite a solid idea of what I want, and then I go and show it to someone and they say, actually, this doesn't work, this doesn't work. Whereas with sketching, it's all about the exploration of ideas. So the sort of quality of the drawings you're doing for wireframes needs to be a bit better. They're really an outline of the interface. So they have quite low visual design because you are usually either hand drawing them or maybe mocking it up in. I use PowerPoint a lot for doing wireframes, and also there's sort of actual prototyping systems. There's one called, I think it's called Acture or something, I can't say. But it's all about what it looks like, but also how it works, and what the structure of the system is. Those are the things you want to represent in your wireframe. So let's look at some examples. Here are some hand-drawn wireframes. Obviously, this is an app. It doesn't really look like a phone, but you've got the different screens that represent it. So I could quite easily, if that's my system, I could quite easily take that to someone and say, what do you think, how is this going to work for you? And I could get some quite interesting feedback. Again, this is a wireframe. There's no point in entering the content because you're just trying to show where the content would be in this particular one. And then we've got some more examples of hand-drawn wireframes down the bottom. So I think they look a little bit more, sort of almost more finished than the sketches. I'd probably show those to people. I'm not sure I'd show that to anybody. I think we'd do that better if I was doing storyboarding, really. But yeah, so these are the sort of things that I might actually take to someone and show. So there's loads of examples of wireframes online because people are willing to show those. Sketches not so much, wireframes is loads. The important things that you need to include in a wireframe are, one, the content, two, the function. You need to make sure that somebody looking at your wireframe understands what they're trying to do with the product. Any navigation, so if that is important with your system, which usually it will be, then you need to make sure that's represented somehow. So in this one, you've got the kind of navigation bar at the bottom, here we've got it at the bottom again. But the navigation is important. And often these things are annotated. So we've got some little annotations up here, sort of with further explanation of how these wireframes are working. But you don't have to, you don't have to draw wireframes. Wireframes also work really well if you do them using these kind of screen-based systems, electronic systems. I think this looks like it's been done in Acture for me. It's represented the space. You've got some aspects of the visual design and the groupings going on that we can see. And then this, obviously, quite clearly, you show it like this. It's quite clear iPhone app. One of the things you need to be careful when you're wireframing apps is that apps don't just run on iPhones. I mean, I love iPhones, but people have, I believe there are people who don't have iPhones, who have like Samsungs or something. So actually, mocking it up on an iPhone, sorry, I just offended like half the room. That's what I don't care. I wish I did care, but I don't. So yeah, these, if you show it in an iPhone, someone's going to think you're just doing it for an iPhone. So sometimes it can be better to kind of make it look a bit less like an iPhone. Yeah, so sketches are not prototypes. So sketches and wireframes are different. And here is just a really nice diagram explaining why. The ideation process is continuous. Okay, it's not mutually exclusive. It's not binary. These things lead to one another. So you start with a sketch, and sort of that means that it's disposable. It should be disposable. It's all about exploration and uncertainty. Once you get into the prototyping stage early on in the ideation process, then what you're developing is less disposable. You're not going to want to throw it away because it's looking closer to what your finished system is going to be. And it's all about refinement and certainty. Cool. So hopefully what you've learned from this is that it doesn't have to be fancy to be useful. And in fact, quite often, the fancier it is, the less useful it will be. Because the objective here is to refine your ideas and make sure that your system works well for the users. And also that you need to be using the right tool at the right time for the right purpose. So if I'm sketching late on and showing that to users, that's not really going to be ideal because I'm not necessarily wanting them to get involved in that kind of exploratory process of design. But yeah, so let's do some more work. So yesterday I asked you, and you're like, oh no, I thought we had a week. Yeah, you do have a week, but you should have probably already done something quick. you used. I'm guessing if anybody here did not use one of these things yesterday, please raise your hand, okay? Did anyone not use the mobile phone, television, e-book reader, the library? That's not how you spell library, is it? Yeah. It is. Ooh, library catalogue, Facebook, Twitter, Amazon, Reddit, a computer or a laptop, an MP3 player, or a cash machine. Did anyone not use any of those things yesterday? See, so you all have to take part. So pick one of these things that you used yesterday, so it is a familiar product to you, and discuss the underlying concepts with your neighbour. If you can't think of any, then you can discuss what you think they might be and kind of explore that. And also think about what interaction styles you were using when you were using that particular system. Pause and discuss, and then we'll come back. Okay?